All right, good morning, good afternoon, good evening, wherever you're at. I hope you're doing good. We're about to get into the second section on this probability portion here. Just double checking to make sure that was working right. So we've got a couple of key terms here. So we're going to be talking about probability distribution, okay, how things are spread out over a whole set, and then frequency tables. Okay, and I'm pretty sure that you guys have seen this before in one form or another, but let's just dive into it and see how we do. So, key terms, frequency table. I'd like you to go ahead and jot these down for me, and then we will take a look at some examples of these. So, the first one, frequency table, is the data display. So you can go and write that down. The data display that shows how often an item appears in a category. Okay, the data display that shows how often an item appears in a category. I put down here as a reference example 1. So if you look down at example 1, you've got that frequency table, and types of music preferred: rock, hip hop, country, classical, alternative, and other. And then, people have come along in this survey and answered these questions, and so you can see how many of each types of music were preferred by these people that were surveyed. Relative frequency is the next term, and so the ratio of the frequency, the ratio of the frequency of the category to the total frequency. Okay, and so again, we're going to be looking at that type of relative frequency in example number 1. We'll get to it there on letter E. So if you want to put example 1, letter E, you can have an example for yourself. Probability distribution is the probability of each possible outcome. Probability of each possible outcome. And you're going to see that primarily, I think it's in example 3, letter A. So if you want to put a reference there, you can do that. So let's actually take a look at some of these examples here and see how these terms can play out within some problems. So in looking at number 1, it says this: the results of a survey of students' musical preferences are organized in the frequency table. What is the relative frequency of preference for each type of music? Okay, so as we look here, in most of these problems where we're looking at relative frequency, we need to know what the total number of people surveyed are going to end up being. So if I add these all up right here, you're going to end up getting 40, total of 40. So 10, 17, 25, 30, plus another 10, 40. Yeah. Okay. Now, if we want to examine let's see here, relative frequency for the preferences within this chart over here, and we want to look specifically at rock, what's the probability of a student coming by based on this survey and choosing rock? Well, it's going to be 10 out of the 40 possible. Okay. Now, I would just get in the habit of always reducing down my fractions there, guys, so that's what I would do. 1/4, and of course you can write this as a percent as well. And so there's a 25% chance someone's going to choose rock that's going to walk by based off this survey here. Classical, well, you probably could go ahead and answer these next 3 pretty quickly and easily now that you know what's going on. And I'd encourage you to go ahead and do that. So as I look at classical, we've got 5 out of 40. Again, I can reduce that down to 1/8. And what is the percentage of that one? Well, that's going to be about 12.5% chance. About half as much as the classical. And we see that in the original numbers, 10 to 5, 25% to 12.5%. Hip hop anonymous. When we take a look here, we're looking at 7 out of 40. 7 is prime, that can't be reduced, and so as a percentage, we're looking at approximately 17.5%. Okay, 17.5% for the hip-hop music there. And then the country music, if I look there, we've got 8 out of 40, and that'll be a 1/5 probability or 20% chance. Okay. For letter E, it says, without calculating the rest of the relative frequencies, what is the sum of the relative frequencies for all the types of music? Explain how you know. Okay. So if you have to answer in one of these categories right here, if we were to take the relative frequencies of all of those and add them up, what should it be? Well, it should be 40%. We've surveyed 40 people. 40 people have answered the survey, and as a result, 100% of our survey is present. Okay, and so yeah, all of those probabilities added together, all of the relative frequencies added together should be 100%. All right, taking a look at the next part, there you go, sorry, clear that off. Always takes me a moment to get used to the new formatting when I'm taking a video here. So taking a look at the next problem, it says here, calculating probability using relative frequencies. A student conducts a probability experiment by tossing 3 coins, one after the other. Using the results below, what is the probability that exactly the following will occur in the next 3 tosses? Okay, and so we're going to start this just like it's very similar to the last problem, and you can probably figure it out on your own. I always want you to try to do that because I think that builds confidence in how you solve these problems. But if you're not sure, you can follow along. The total number, if we were to add all this up, I believe is 50. Let's double check that. 12, 21, 27, 29, 38, plus 12 more is 50. Okay. So from there, what's the probability of getting 2 heads? Now what we need to identify here is which ones would have at least 2 heads. Or no, has 2 heads, exactly 2 heads. So no, no, yes, no, no, yes. Oh, wait, I'm looking at tails, aren't I? Let's try that again. 2 heads, has 2 heads. Yes, 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 and that's it. Okay. So again, I made a mistake on those. Oh, that one has 2 heads on this one. Okay. All right. So if we go ahead and take a look at that, there's a chance of 7, 6, and 2. So if we add all those up, 7, 6, and 2, out of the total possible that we were given, we end up with a total of 15 out of 50 chance. Now, again, I would get in the habit of reducing this down, dividing both those by 5. You end up with 3/10, which is well, that is exactly 30%. So about almost 1 in 3 chances that you're going to have 2 heads out of the 3. Okay. For this experiment here, if 1 head, probability of getting a 1 head. Well, in this one, if I look up here, the probability of getting 1 head would be here. No, no, yes, and yes. I got them all. I think that's good. Okay. So if we add those up, probably getting 1 head, there's a total of 20 out of 50. And if we reduce that down, you end up with 2/5, which is exactly 40%. Okay. All right. So again, not meant to be hard. Just make sure you, I guess, focus on what we're asking for. Look exactly at that. Don't be distracted by these other ones that have at least 1 head. That's not what we're asking. We're looking for the ones that have 1 head. Looking at the next one here, all 3 are tails. Well, if I go along, No, 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 yes, no. Okay, so all three are tails. I only have one of those. And so in the end, if I reduce that down, you get 20% chance of getting all three flips as tails. Okay. The last one, at least one tail. Okay, now this one, make sure you're looking at all these. Is there at least one tail in that first one? No. Is there at least one tail here? Yes. Okay. Is there at least one tail here? Yes. 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 In fact, yes. And then yes. Okay. So there was only one scenario where there wasn't at least one tail. So you can do this in actually one of two ways. The long way would be to go ahead and add up all these like we've been doing. So 7 plus 9 plus 6 plus 2 plus 9 plus 10 plus 2, and all that is over 50. Okay. So if I add up all those, let's see here, we should get 45 out of 50, which if I reduce that, dividing both those by 5, I get 9/10, which is 90%. Okay? But the easy way would be to go ahead and take the sum of all the relative frequencies, which we know would be 50 out of 50, just like that last problem. What was that letter? E. Okay? And we're going to subtract out the probability of having 0 tails. And then instead of it's at least 1, the probability of 0 tails would be right there. So if I were to do this, probability of 0 tails. Is that going to show up? Tails. There you go. Okay? So if I go ahead and take the difference there, you, again, get the exact same answer. Okay? All right, so I hope that was understandable. I mean, it's all right there. We just have to know how to read the problem correctly. All right, now let's move on to the next problem, to the back side. And here's what the problem says. A student conducts a probability experiment by spinning the spinner as shown. Using the results of the frequency table, what is the probability of the spinner, that the spinner points at the following on the next spin? Okay, so I look up here, here's our spinner, okay, and here's our frequency table. Again, I would probably go ahead and solve for the total number, adding up all those together. If we do that, this is going to end up being 100, okay? Now, from there, the probability of getting 4. Well, if I look there, the probability of getting 4 is 18 out of 100, which, if you want to leave it as a ratio, would reduce down to 9/50ths. Or if you prefer a fraction, well, that's real simple. If it's 18 out of 100, just 18%, okay? What's the probability of getting a 2 or a 3? Now, when we see this or, I can bring both of those together, okay? In fact, as I look up here, if I was just looking at this right here, just the chart, not knowing anything about this frequency table over here, that the experimental probability had already been run, just looking at the chart, what's the probability of getting a 2 or a 3? That's 50%, right? It's half the chart. So as I look at this, let's see what we end up having. Experimentally, when we did this, we had 32 that came up as a 2, 21 that came up as a 3, and so 53 out of 100 would have been our based off the frequency chart, okay? And so in the end, 53%, there's a 53% chance that you're going to spin a 2 or a 3, okay? Slightly greater than a 1 or a 4. Now, the next one says a 1 and a 4. Now, the question I would have for you guys is this. Is it possible in one spin to spin a 1 and a 4? And the answer is no. You either have to spin a 1 or a 4. You can't spin a 1 and a 4. And so as a result, I'm going to put down 0 out of 100, which is 0%. And you may want to make a little note of that down below. You may want to just tell write down, cannot spin a 1 and a 4 if I'm spinning just one time. Okay. If you're spinning twice, then it is possible to spin a 1 and then a 4. Okay. Probability of getting a 5. Well, if you look over there, there is no 5. And so, even on the frequency chart, there's no 5. And so, 0 out of 100, again, 0% chance, okay, of spinning that 5. All right, now, moving on to probability distribution. Let's take a look down here at this next problem. All right, so we're at an archery tournament, it looks like. Oh, didn't mean to do that. And there we go. Okay. In a recent competition, 50 archers shot 6 arrows each at a target. 3 archers hit no bullseyes. 5 hit 1 bullseye. 7 hit 2 bullseyes. 7 hit 3 bullseyes. 11 hit 4 bullseyes. 10 hit 5 bullseyes. And 7 hit 6 bullseyes. Create a probability distribution of the bullseyes hit. Okay. So you'll want to do something like this, where we have this number of archers that hit the bullseye at different rates. So I'm going to go ahead and say number of bullseyes hit. Okay, and I'm going to put down here frequency. Okay. Now, I probably should have put down another row down here. After I put down the frequency, we are asking for the probability distribution of the bullseyes. So I'm going to put down here probability distribution. Okay. So from there, number of bullseyes hit. We're either going 0 through 6, 2, 3, 4, 5, and oh, you know what? I'm going to have to add an extra column over here. Okay. There's 6 possibilities there, so I'm going to put down the 6th one over there. Okay. Now the frequencies, if we read through this here, it says 3 archers hit no bullseyes. So I'm just going to fill in 3 archers hit 0 bullseyes. Okay. 5 hit 1 bullseye. 7 hit 2 bullseyes. 7 hit 3 bullseyes. 11 hit 4 bullseyes. 10 hit 5 bullseyes. And 7 hit 6 bullseyes. Okay. From there, we actually want the probability distribution. And so if I add up this row right here, okay, the total number of bullseyes is going to be 50. Okay. And so, in fact, we get that right there. If it matches there, we know we've done a good job, because if it doesn't, we put something down incorrectly. And so the probability distribution becomes really simple. It's just the number hit over the number that could have hit. Okay. Now the question I would have right now would be this. Should I be reducing my ratios? I do like my ratios always to be reduced, but I will tell you this, the text to which I am getting this information from for you guys, it doesn't show these ratios reduced. And so I'm not going to mandate that you have to reduce those ratios. Okay. Determine the probabilities for part B for the following. The probability that you get 3 bullseyes. Okay. Well, that one's very simple there. You've got your 7/50ths, right? All right, and if you want to leave it as a percentage, you can. Okay, 14%. The probability of getting 6 bullseyes, now that I've got the probability distribution, it's really simple. I just look up there and I can see 7/50ths. Or you could go ahead and write it as a percent again, which would be the equivalent of getting 3 bullseyes. Okay? All right. You can go ahead and take a look at the next problem. Actually, I think I'm gonna skip that one. The probability distribution for the next one, you're just gonna set the number that got the certain score over the total number. So I'm not too worried about the education one. The error analysis is an interesting one, and so let's take a look at that one to finish things off here today. Oh, did not mean to do that. There we go. Okay. So if we look here, it says a friend says that their sweepstakes ticket will either win or not win. So the theoretical probability of it winning must be 50%. Explain your friend's error. Oh, I wish the tickets that I buy, which I don't usually, would be a 50% chance of winning. So why is this an error? Well, I'm sure there are probably different answers that you could come up with, but what I put down was something like this. This would be true if only one ticket were to be handed out. Okay? One ticket would be handed out. You could probably even put down 2 tickets handed out. One wins, one loses. Okay? But as soon as you increase that and there's only one winner, the probability is going to decrease. And so, unfortunately, that is not the case with most sweepstakes. By definition of probability, we must determine that the number of favorable outcomes, usually just one, over possible outcomes, many times hundreds, if not thousands. Therefore, the probability of winning is much less than 50%. Okay? And so I guess when I look at this type of problem, I don't know if your parents have ever gotten one of those keys in the mail from one of those local car dealerships, you know, and like, this could be a winning key, starts the car, you win the car. And I kind of chuckle at that, because if you look at the bottom of each of those flyers, they do give the probability or the odds of winning. And it's almost comical. The odds of winning the car is like 1 in 100 million or something like that. I mean, it is really, really against you. And so the same thing with the lottery. The lottery is not in your favor, and that is why the lottery is there, because it does make money. Everybody plays to get lucky. So anyways, that is all I have. My phone is going off. I hope that this is understandable. Make sure you do your homework, and we'll talk to you tomorrow. Have a good day.